Hi, this is Stephen, and I'm just going to give an introduction to the cable calculation box. This is probably the most important tool when it comes to selecting your cables correctly. I will run through everything from the beginning. So the first thing is I'll create a new cable and then edit the cable. While I will be using the cable edit form to demonstrate the calculation box, I won't be going into any detail. If you're interested in this, we do have other videos, and I suggest you watch those after you finish this one. The first thing to talk about is the positioning of the calculation box. As you can see on my screen, it's on the right hand side. This is because my screen is reasonably sized and the aspect ratio sort of pushes the box to the right. If you're working on a smaller screen, the box may be closer to your edit form, or in fact may overlap the edit form, as I've demonstrated just now by changing the width of my browser. If the box does overlap the form, you can turn it off by clicking the calculation box to view the form, and when you want the calculation back again, you can turn it back on. If you're using a desktop, as I am, when you initially edit a cable, the calculation box will be visible. If you're on a smaller device such as a phone, initially the calculation box will not be visible as it takes up most of the screen. On that type of device, your workflow will be to complete the form, switch on the calculation box, see the results, switch off the calculation box and carry on working. For the rest of this video, I will just adjust my screen so the box is just off to the right hand side and we can see both it and the cable edit form. The first thing to notice about the calculation box on a new cable is that there are no calculations, but instead we have some configuration hints which guide you in what you need to do to complete the form. In setting up the form for a cable initially, we do two things. The first is we populate some default values. For example, you can see on the form we have 400 volts, 50 Hz, 100 amps. Having said that, there are some parts of the form where we don't have default values, particularly the cable selection and cable installation. Because these particular fields have not been completed, there's not sufficient information for the application to do a calculation. So what I'll do now is I'll start working through the messages on the calculation box. The first is no cable selected, so let me select a non-armored cable, 4-core, and it's asking me to select a cable size. I'll talk more about this shortly, but for the time being I'll just select 16. The next message indicates that there's no UDR or user defined rating set. Now every cable has the ability to have a user defined rating. This is the sustained current rating for the cable. It's shown by default because it does apply to every cable, where in some instances standards, for example BS7671, will only apply to low voltage cables. This is useful if you know the rating of the cable. If you've been given it by a manufacturer, perhaps you've taken over the cable from the DNO and they've given you a rating, or you've calculated the sustainable current rating outside of our application and you want to use the result of that calculation within our application. While we have the option, it probably is the least frequently used option, as most people do want to size cables. So to do that, we typically select a sizing standard from the drop down menu. I have selected BS7671. Now the calculation box is telling us we need to select an installation method, so I'll go ahead and do that. And now that we have sufficient data in the cable, the calculation box is giving us a summary of the results. The result summary is divided into several sections: current capacity, voltage drop and fault rating. These are the main sizing parameters and we have them listed in the order that we'd recommend you work for your cable. We also have a fault loop impedance, which is shown for low voltage cables, and at the bottom we have some additional cable information which can be used. Looking at the first item, current capacity, the calculation box tells us the sighting standard we've selected, and then it provides us with the rated capacity of the cable, that's a sustained current carrying capacity, the design current and the cable current. In this instance the design current and cable current are the same because there's no protective device selected. The current capacity is also giving us a suggested CSA of 16mm squared to meet the requirements of BS7671 for sustained current capacity. That does happen to have been the CSA I selected. If I, for example, increase the cable current to 200 amps, we can see now that the current capacity traffic light at the top has changed to red, indicating there may be an issue, and the suggested CSA required has increased to 70mm squared. If I go ahead and change the size to 70, and the calculation refreshes and everything's okay again. You can of course continue changing other fields on the form, parallel cables, number of circuits, temperatures, installation methods, and very quickly run different scenarios to see the effect of these on your cable. The next section down is voltage drop, or potentially voltage rise depending on your system. It tells us the actual voltage drop is 0.03%, which is less than a specified maximum of 3%, and so we have a green traffic light. Fault rating calculates the short circuit I squared T, earth fault I squared T, based on the parameters given on the input form, and compares that with the allowable I squared T of the cable. In this instance everything's okay. And then we have the earth fault loop impedance. Here it's just telling us the value of the impedance because we have no protective device. If I select a protective device, for example an MCCB, then you'll see that the earth fault loop impedance now is not only shown as a calculated value but a maximum allowable by BS7671. The information at the bottom of the box is purely there to help you calculate the cable. We have the impedance, we've also got the cable power loss, and we've also got the conductor temperature. And really that's all there is to the calculation box. It is simple, but it does contain a lot of information related to your cable, and by using information you are able to run scenarios very quickly and ensure that you do really select the best cable for your application. Thanks for watching the video, and if you haven't tried our cable sizing application yet, please do so. You can visit myCableEngineering.com, register as a user, and you'll be given some free time to try out the application and see if it's suitable for your needs.